Let me share my desktop. Yes. So in the last session, we talked about filter transformation, right? This is one of the simple transformation. Prior to that, we talked about hierarchy builder. Yeah. Okay. So with filter transformation, yeah, so we can start limiting the number of rows based on the simple filter condition or based on what compound filter condition. Yeah. So that is what was discussed in the last session. Yeah. Now, what is the limitation with this particular what this particular filter transformation? I repeat. So, what is the limitation? So that we have with a filter transformation, right? So to answer that, so we can start getting into what another transformation, which is a router. The issue is what limitation is what one spawn overhead and second data transfer overhead. Yeah. So these are the two overheads we have with this particular what filter transformation. Spawn means for every condition we need to have separate filter transformation, right? Yeah. So we need to create a separate filter transformation. Yeah. Fine. So which means it has to create a new thread. That's a spawn overhead. Yeah. And second is what data transfer, because for every filter, separate filter, so we should pull the data from the source. How do we pull it? By using what? A link. So that is where you will have what data transfer overhead. These are two overheads we have within this particular filter transformation. Now the question, how are we going to fix or resolve those overheads? So that's going to be the question mark. Yes or no? Yeah. So that's where we have got router transformation. Yeah. So the router transformation is going to help us to limit the data in the sense conditions, all that. It is exactly similar to filter, except these two issues we can solve it. So we don't need to spawn, no spawn overhead, because with one router transformation, we can build n number of conditions, right? And second, because of no separate filter or no separate router, data transfer also not be there. So this way, we could able to eliminate the issues that we can see by using what the filter transformation. Clear, right? So that's it. Yeah. Yeah. Now let us try getting into what doing it practically. So practically, right, similar to switch case in any programming language, right? See, we got in any programming language, right? If if else, then we have else if ladder. So else if ladder, and then we have switch. These are decision making statements, right? So out of these n number of decision making statements, the topmost and optimal decision making statement is what? Switch, where we can specify the label, switch with the label. So within that, so we could able to find or supply case label. You know? So like for example, case 1, case 2, case 3, whatever, right? If the label value is, let's say, 1, control comes here and apply any logic here, then break it so that it will come out from this particular case block. Same way, it will be repeated for n number of case statements. At the end, you will have what? Default block, where we can apply default logic and then break. So that's it. Which means in this case, what happened? No fall through would take place, in the sense, whenever one of the case block gets satisfied, the control comes out from that particular switch statement. So that's what happens with this particular switch decision making block. But whereas else if ladder, even if the first else if got satisfied, it will just proceed further to evaluate next else if ladder. So such things we cannot avoid in this. So that is why switch is an optimal decision making statement. So in Informatica, we use what? They have just named this different name, router. Same logic, like whatever we do in switch, same thing we do it by using what? The router transformation. Yeah. So within router, we can add n number of subgroups. Yeah. For example, subgroup 1 will be used to take care of filter condition 1. Yeah. And subgroup 2. Yeah. So subgroup 2 will be used to take care of the filter condition 2, and so. Yeah. So that's what we can see as part of what the router transformation. And in case if you have any rows which are not satisfied with this particular filter 1, filter 2, right, then those things will be captured as part of what? Default group. This way, there is no way of losing any data with the router transformation. We can capture all the rows, matching ones, unmatching ones, which means matching ones means the data which satisfies the filter condition. Unmatching ones will be sent to default. So we can, if you want, we can capture unmatched ones in a separate target, matching ones in some other targets. This can't be done with this particular filter, which is else if ladder. We have to explicitly specify what a filter condition, only the records which satisfies that particular filter condition, only those rows will be transferred to a target. Yeah. So that's it. Clear, right? Now let us try doing it. Yeah. Okay. So source, then we need to go with the router. So yeah, we just have to supply the file. Yeah? These are very elementary transformations because I need to cover all, right. That's why I'm covering at least 1 or 2 examples. Yeah. So complicated ones will spend more time. Yeah. Like unstructured to structure conversion or SCD or customizing task or task flows. Yeah. And then velocity transformation. So there are some complex things. We'll spend more time on that. So now let us configure the router. Here we can add what multiple output groups. So you can see, right, default group, which means if you don't have any subgroups, then results will be sent to default group. Yeah. Click on plus and we can supply any name here. Let's say group 1 and click on configure. C1, let's say equal to 1. We are trying to do exactly similar to what we did in filter. Yeah. Let us start with this. C1 equal to 1 will be captured in one target. Rest of them will be sent to default. Yeah. That's what I think we discussed in theory, right? Default block. Yeah. Okay, now let's add two targets here. We can expand this by using a plus button here. Then add one more target. So default. Yeah. Okay, this is done. Now let us add target. Okay. The file name, let us say filter1, filter underscore 1, based on C1 column dot txt. Yeah. Say okay. Now second target. Second target connection and supply file name. Yeah, I'll just put here default target. Yeah. Say okay. Now we can supply the mapping name. To supply mapping name, right, we need to click on this mapping workspace, not on these blocks, like a target, source, route, transformation, whatever. Outside this. Yeah. Then you can see mapping properties. Supply mapping name, mapping underscore router with one subgroup. Okay. And run it. Yeah. Run this. Yeah. Okay, let us refresh it. So it got completed. So you can see metrics here, like how many rows are in default, how many rows are in user defined group. See, 5 rows are user defined group and default there are 6 rows. So total rows are covered. So there is no way of missing any data with this router. Yeah. Now let us see. So this is the first one. So 4775 empty. So then default target equal to 1. Yeah. So we give wrong names actually. Looks like, see, target 1. So we give default actually. It should be opposite. This is equal to 1, right? Default is what? Other way. Filter C1. Yeah. So other than that, anyway, only name changes, but the results we got it anyway. So that's it. But if you want to build complex condition also, we can do it like what we did in filter transformation, right? Same thing, we can also do it here. Yeah. So click on plus and add another group name, group 2. Yeah. And click on configure and supply. Let's say C1 greater than 1 and C1 less than, let us say, 7. Yeah. So we can also go with advanced. So in this step, by default, it is going to make use of and logical operator. Yeah, let us say that. I didn't talk about it as part of filter transformation. So this and will work with a simple filter. But if you want or not, right, then we need to go with what? Advanced option. Yeah. And then we can add another target. So here we can map group 2 to target 2. Yeah. Okay. Supply file name, which is, so I'll just put general name, which is a group2.txt with what and logical operator. Yeah. Say okay. That's all. Yeah. Now let us save and run. Yes. So now let us refresh this. So we got all the 11 rows, but some will be distributed to another target. See here, now in default, we got less now, 3 only, and 6 in C1 equal to 1. And this is AND operator, which is greater than 1, less than 7, whatever. Let us see that. And group 2, right? See, greater than 1, less than 7. C1, 4, 5, right? So that's it. Yeah. And filter 1, I think this we already discussed. This is same. We did not touch anything. Yeah. Now the question, if you want this or, right, with a simple filter, we cannot do it. Yeah. So now let us see how we can add that also. Yeah. So let us say group, sorry, group 3. Yeah. So here you can just select advanced and define filter condition. Yeah. That's a C1 greater than 7 or C1 greater than or less than, you can put less than 3. Yeah. Or greater than 7 or less than 3. In between, right? Like we have 4, 5, those things will not be covered. Let us see. See, resolve operands mismatching types, which means we need to use what type change. Yeah, I think as Sravanti was saying, using expression transformation, we could do it, or so within the source itself, we can change. Yeah, but but in reality, right, we should always try to avoid the type conversion as much as we could. Yeah. So because if we try to apply type conversion, right, there is going to be proportionate overhead. Yeah. So now let us see this. So let us take this. Yeah, and validate. Yeah, see now it is valid because of the type. Yeah, I think we face same problem in even normal filter also when we used advanced with the AND logical operator. So that's all. So now we covered advanced simple with logical within a same router transformation, right? So let us refresh this. See, we can see all the rows covered here. Now we can see the metrics because so we need to look at the effect of this OR condition, right? Yes. So we got only 3 rows, huh? But we expect 4, right? One sec. I think we did not map it. Target is not added, huh? Yeah, that is a problem. Okay. Okay. So this is what yeah, okay, router underscore or target, right? Yeah, let's run this. Okay. So let us refresh this. See, we got now more rows. Why? Because our condition. Let us see. So group 2 and operator or operator. See here. So we got less than 3 we gave, right? 1. Greater than 7 we don't have data. Yeah. So some rows here. And then yeah, we can just look at the metrics. So yeah, here we got 3 rows. Repeated rows actually. So in router R, there are 6 rows. Here also there are 6 rows. 6 rows extra we got it because of R condition. But missing data, it will be captured in the default target. So that's it. Yeah. But here it's a repeated actually. Here and here, though we got separate condition. Yeah. So that's it. So which means whatever problems that we have in this particular filter, right? So which is data transfer and spawn. Those 2 things we can solve it because if you look at this router, so we got only one router, so no links, right? No transfer. And spawn means only one router takes care of all. We don't need to have separate thread for another router or another condition, whatever. That's it. Yeah. That's about router transformation. Yeah. Now, let us start getting into another simple transformation, which is, let us say, aggregated transformation. This is usage wise, it is very simple, but performance wise, it's very expensive. Let us talk about it. Why? It is easy with respect to usage and why it is complex when it comes to what performance. Yeah. So this particular transformation will be used in order to perform group by operation. Yeah. So I repeat, this particular what aggregator will be used in order to perform group by operation. Right? Yes or no? Yeah. So for example, we have got a sum, average. So average, standard deviation. Yeah. Then we have variance. Then we have whatever, first, last, whatever. There are multiple what we call statistical functions we call, or aggregator functions, or group by functions. They're all synonyms. Yeah. Now that's a concept. Now let us take some real-time examples. Let us say there is a manufacturing industry where they produce different kinds of products. Now let us say we need to obtain the count of all the products with a product shape, like a tra- trapezium shape or knurling shape, what I call triangular shape or whatever. So the type of product is going to be the group by in this case, or we can say product type. Yeah, product type is going to be what group by, right? And then the column which will be used for calculation, it could be simple product, product number, or whatever, or some product, some other attribute. You know, so product number. That's it. Which means, in order to perform this aggregator, we have to have two inputs. One column, which will be used for group by column. Other column will be used for the calculation column. Yeah. So that's it. Yeah. So that's what we do by using what this particular aggregator. Yeah. So that's it. Yeah. Like how one can start taking care of aggregator operation. Clear, right? So that's it. Similarly, we can think of many. Let us take common example: employee department table. Yeah. So now let us say we need to obtain the sum of salary drawn in a specific department or in each department. Then in that case, what we do here, calculated column salary from the table, let's say employee, then we can perform group by, which is based on department number. That's it. So with this, what happens? We are using group by column as what? Department number, and salary column will be used for the calculation, right? So that's it. Like how one can perform aggregation here. Second example. Likewise, you can think of many more examples. Yeah. So in our sample data, SEQ1, simple file, right? So here we can use C1 as a group by. So we got similar rows, right? Then C2 will be used for the calculation. That's it. This is a concept. Yeah. Now how it works? Simple. So its usage is very simple. Now how it works? Usually what happens is pre-sorted data, if you take it as input, then aggregator happens faster. Yeah. I repeat, if you have pre-sorted data, then aggregation happens bit faster. Yeah. If not, aggregator, what it does, it is going to sort, then index, then group it, then perform calculation. These are the steps. One of the steps will be eliminated if you already have pre-sorted data. Yeah. This is what I can say is a kind of if you already have pre-sorted, then we can use it, or else directly aggregator also we can do it. Yeah. Plus, I'll talk about some optimal options in aggregator, like a data cache, index cache. Yeah. So we'll talk about it. Let us understand first how to configure to get the job done of aggregator. Yeah. Let's see. Yeah. Any questions in this aggregation? So aggregation is looks very simple. It's very complex. Not from the usage in reality, because it's one of the very expensive transformation, because it expects a lot of computation power, which means how do you expect computation power, or from where you'll get computation power? From CPUs. So we have to have more CPUs to get the job done for aggregator, where we have got very, very large data sets or large volume of data. Yeah. So let us build a mapping. Yeah, take aggregator. No configure source. Yeah, now supply file name. Yeah, first file. Say okay. So there are three. So usually we use aggregate to perform numeric operations. So it's better to go with what? Numeric type. Yeah. But yes, string also we can use it, but for some of the aggregations, right, you may not get the expected. Sometimes job would get aborted. That is why it's always advisable to choose what? Right type, so that we can expect the right result in the target. Yeah. So let's say integer is first one, second is also integer, because one for group by, second is for calculation. So others we don't need to worry, right? That's about the source part. Yeah. Then aggregator. So click on plus and select what we want. Yeah. And configure aggregate. Yeah. So let us say we'll start with the first one, which is a count, which means count of records in each group. Which means if you have one, within one, how many records are there? That's what it means. Huh? Count result. Yeah. So we can use what? Integer. Say, okay. So now if you go to built-in functions, right, we can say separate category called aggregate. Within that, we can see all the supported functions from aggregator. Yeah. So let's use this. See, now group by we selected, and C2 we are using it for calculation. That's it. Yeah. So whatever theory we discussed, right, same thing we are trying to do with the practical. So I'll also try to show with the tables. Anyway, concept is same. Doesn't matter whether we use file or table. That's it. Yeah. Now let us configure the target. Yeah. So I'll just put your count result, right? Txt. Yeah. Then say okay. Underscore count. Yeah. And save it. And then run. Yeah. So let us refresh this. See, we got 5 rows. So total count is more than 5, right? So aggregate is what? Active transformation. Active means what? Where there is a change with respect to number of rows would take place. Yeah. Now let us see. Changes happen, right? Input count is different from output count. So input is how much? We can see SEQ1, which is greater than 5. Yeah. It's a 5 plus 5, 11 on 11 rows. 11 rows converted to 5, which means change happened, right? That is why it is an active transformation. Yeah. Now let us look at the count. See, within group 1, how many rows are there? 1, 2, 3, 4, 5, 6. 6 rows are in what? The group value 1. Similarly, under 7, there are 2. And rest are all unique rows. Yeah. Now let us see the result. Yeah. Yeah. Count result. See here. So now with the group value 1, we can see count result is what? Which is 5. Yeah. And group value 7. What is the count? We can say 2. That's it. Yeah. So that's what we can see as part of this target. I hope it's clear, right? It's very simple. Usage is very simple. It's very complex. I'll talk about algorithm also, how it works. That much may not be required, but yes, I just tried to touch upon on that. So that's it about the starting point of aggregator. Now we can extend this to perform what other sort of aggregators. For example, how to perform sum. You know? So let me open this. So we can have separate aggregator or same aggregator also we can perform just to have the clear separation, right, from count with some other mathematical operations, right? I'm just using some other aggregator, yeah, or else it's not required. Yeah. Yes. Now we can say sum, yeah, sum result. So based, you can specify the type here, let's say integer, and then say okay. So click on configure. Yeah, same procedure. Go to built-in functions, aggregate. So here we could able to see what sum. Yeah, that's it. So we can specify second column, which will be used for the calculation, right? And click on validate. That's all. Yeah, and then say okay. Yeah. So now let us capture this in the second target. Yeah. So let's click on select. Supply the target file name, yeah, which is some result, yeah, from group by, yeah, group by C1, right, dot txt. Okay, this field mapping, right? So I didn't talk about it. So this is required when we use existing target. Now we are using new, right? So we don't need that. Yes. Now let us try to run this. Yeah. Now let us refresh this. Say we got 10 rows now, which means 5 for the first target and 5 for the second target, right? So now we can see the result sum, right? So within one, we got, I think, how many? What is the count here? 5. Yes, there are 5 rows. And if we try to apply sum, right? 2 plus 2, 4. 4 plus empty, nothing. 4 plus 1, 5. 5 plus 10, 15. 15 plus 118. So, so 128, 133. Yeah. Yes, 133. Right? Simple sum. Similarly, other values. I think we have got 2 rows in this with a group value of 7, right? Yeah. Group value is 7. So there is a 22 here plus 8. 22 plus 8, 30. So that's what we can say 30 here. Yeah. That's all. So rest all unique records. So we don't see any difference. Whatever output we have in 5, right? It's a C2 column. Same thing we'll have it here. Here 122, here 122. Here it's different. Here 22, 30 because there are two, right? So 22 plus 8. That's it. So this how the calculation happens. Same way. So you guys can take care other aggregations like average, first, last, whatever, right? You guys can take care. That's fine. Now let us talk about other properties within this aggregator. Yeah. Before that, we can also have multiple group by columns. And if you use aggregator multiple times in the same mapping, right, we need to select incremental aggregation. It's the optimal option. Yeah. I'll talk about optimal for later. For now, just remember that point. Yeah. And aggregate also, we can have n number of aggregations here. You can add a plus. Let's add one more here. Let's example max. Yeah. So max result. Just to indicate like we can have n number of aggregations in the same aggregated transformation. Yeah. Take this max based on C2 column. Yeah. This validate. Say okay. That's all. In the same target, you will have two results, sum and max. Okay. Let us refresh this. So we got 10 rows only because we use same aggregator. We did not use some other. See here, you can say max result. If you take group value 1, yeah, which is 1, which is a maximum value for C2, 2, 2, MT, 5, 8, 1, 1, 8, and 10. Out of them, Max value is what? 118. That's why you can see 118. With the 7 also there are two rows, 22 and 8, right? I think we have seen that. Yes, this is 8 and 22. Max value is what? 22. Yeah. So that's it. Like how one can start performing the group by operation. Fine. So that's enough. So now, yeah, we can start getting into what advanced options. Yeah. So as you discussed earlier, if we have pre-sorted data as input, we can enable and see whether we could able to get the result after sorting or not. Then we can see cache directory. You can specify data cache, index cache. Yeah. So, but how we calculate data cache? It's based on what number of rows and the column that we use for calculation. Based on that, we need to calculate a cache size, which is data cache size. Index based on the keys that we use and supply the value. There are optimal options. I'm just giving some clues. I'll elaborate when you talk about performance tuning techniques. Yeah. So yes, sorted part. So I'll talk about it when you talk about sorter transformation. Because if we include sorter before aggregator, then only we can enable it. If we enable without what sorted, right, you'll get error saying that data has not been sorted. Let us see that. Yes, let us try to refresh. See, it got failed. You can see, right? Expecting keys to be ascending. So this kind of issues will get it if you don't supply sorted data as input to this aggregator. Yeah. So we'll fix it on tomorrow's session. So if you have any questions, you can shoot out now. Venkat, Savanthi, and Ajit.
I'm good.
Okay, fine. Yeah, if there are no questions, then we'll stop here. We'll continue from it tomorrow. Thank you very much to all of you, and bye.
Thanks.